Hi, good afternoon. Today I will present you this problem that you can see on the screen. This problem consists of developing one program algorithm in Excel to predict an asentropic binary mixture of ethanol with toluene at 55 degrees Celsius using Margules thermodynamic activity model for the Gibbs free energy. While we will use these equations throughout the procedure, we will use the Margules model and linearization of functions will be used. The equations to use are those present on the screen, but don't worry, I will teach you step by step to obtain the data shown. The program algorithm in Excel should be validated by the following experimental data as you can see on the screen. Well, first of all, we obtain the pressure values x1 and y1 from data provided as well as the data x2 and y2. However, the data x2 and y2 can be calculated using the following equation: 1 minus x1 and 1 minus y1. Well, then we enter the data on the compounds, which will help us to the table. Well, the data for A, B, and C were found from Antoine's table. We obtained the pressure using the following equation that you can see here in the screen for both pressures. And about the temperature, we got it because the problem gave us this data. While using the ELV equation to obtain x1, x2, and y1, y2, we can obtain gamma 1 and gamma 2 with this equation by multiplying y1 by pressure between x1 by saturated pressure of ethanol, and in the same way to obtain gamma 2, the same equation will be carried using y2 times pressure between x2 times saturated pressure of toluene. Well, for the next two columns we will use natural logarithm of gamma 1 and gamma 2. It's that simple. We go to the next column to get g raised to the second power over rt. We use the equation shown where we add x1 times the natural logarithm of gamma 1 plus x2 times the natural logarithm of gamma 2. Well, to move on the next step, a12 and a21 were calculated using the graphical method, which is as follows. We took the data of logarithm of gamma 1 and logarithm of gamma 2 versus x1. Then the data of logarithm of gamma 1 and logarithm result of gamma 2 versus x2, since the Margules model of the following equation shown can be determined. Well, when graphing, we can observe the Margules parameters of a12 and a21, knowing what is show us in the equation. Then the graph projects that for gamma 1 we must approximate the lines to x1 equal to 0, and it is projected to that axis. Now for gamma 2, as we observe in the equation, x1 must be equal to 1. When moving to the next two columns, we use the equation shown to obtain g raised to the second power over rt. We use x1, x2, and the values of a12 and a21 to get delta of g raised to the second power over rt by raising everything to the second power. For the last two columns where gamma 1 and gamma 2 are found, we simply multiply exponentially with the natural logarithm of gamma from the model equation. Then about the graphics. For blue line we use x1 with logarithm of gamma 1. For orange line we use x1 with logarithm of gamma 2. For gray line we use x1 with ge over rt of model equation. For blue line we use the pressure with x1, and for orange line we use the pressure with y1. Well, the references, and thus we have solved the problem using the mentioned methods. It is worth mentioning that it was a challenge to develop the project since new knowledge and methodology and equations to be used was accurate. However, with the help of prior knowledge and investigations of used models, it was possible to achieve to the project. Thank you so much for listening.